Hey there, and welcome. We're going to talk about something you probably walk past every single day and don't give a second thought to. That little panel of switches in your wall. Yep, we're talking about circuit breakers. And we're about to find out why picking the right tiny switch can be one of the most important safety decisions you make for your home. So let's get right into it. Just think about that for a second. A fire that never trips the breaker. That phrase is chilling, right? It perfectly captures the whole point. You have a safety device that's supposed to prevent fires, but it completely fails, letting a disaster happen while it just sits there, doing nothing. This is exactly what's at stake when you get this one simple detail wrong. So, I've got a question for you. Do you actually know what's going on inside your breaker box? I mean, we all know what to do when the power goes out, right? You go flip the switch back on. But beyond that, these little devices are your home's absolute first line of defense against an electrical nightmare. The real question is, are they the right defense? Okay, so let's break down what this hidden danger really is. We're focusing on something called miniature circuit breakers, or MCBs for short. They're the standard in just about every modern home. But here's the catch. Using the wrong one can lead to two totally different but, equally serious problems. So you've got two big problems here. On one side, you have what's basically just an annoyance, nuisance tripping. That's when your lights just shut off for what seems like no reason at all. It's frustrating, for sure. But on the other side, you have a much more sinister problem, failure to trip. This is when there's a real, genuine electrical fault, like a short circuit, and the breaker does absolutely nothing. And that's when wires start to overheat, and the risk of a fire becomes terrifyingly real. So what's causing all this? Why would a breaker trip when it shouldn't, or worse, not trip when it should? Well, it all boils down to this secret little force called inrush current. It's this powerful, hidden surge of electricity that happens every single time you turn something on. Understanding this surge is the absolute key to picking the right breaker. So what is inrush current? Well, it's basically this huge but super short blast of power that an appliance needs just to get going. A great way to think about it is like pushing a heavy cart. It takes a really big shove to get it rolling from a standstill, right? But once it's moving, it's much easier to keep it going. Electrical devices are exactly the same. They need that big initial shove of electricity to power on. And when I say this surge is brief, I'm not kidding. The whole thing can be over in as little as 10 milliseconds. That is literally faster than you can blink. So the circuit breaker has a really tough job. It has to tell the difference between this totally normal, lightning-fast startup surge and a genuinely dangerous electrical fault that it needs to stop. And this, right here, brings us to the solution. See, not all circuit breakers are created equal. They're actually designed with different levels of sensitivity, specifically to handle different kinds of inrush current. The secret is decoded by that little letter printed right on the front of the switch. Now, in your house, you're really only going to run into three main types: B, C, and D. Type B is the most sensitive. It's made for things with really low startup surges, like your lights. Type C is your jack of all trades, the general purpose breaker for things with small motors. And Type D, that's the least sensitive, built for some seriously heavy-duty equipment. First up, we've got Type B. Think of this one as this sensitive specialist. It's perfect for what we call resistive loads, which is just a fancy way of saying things that don't have a motor. We're talking about your basic lighting circuits and your standard wall outlets. Since they don't have a big startup surge, a really sensitive Type B breaker can protect them perfectly without tripping all the time. Next, we have Type C. This is probably the most common breaker you'll find in a home. It's the all-arounder, right? It's specifically designed to handle that moderate inrush current you get from things with small motors, like your ceiling fan, your fridge, or your washing machine. Those motors need an extra jolt of power to start spinning, and a Type C breaker is built to ignore that normal startup surge, but still trip if a real problem happens. And finally, there's Type D. This one's the big guy, the industrial heavyweight. It's designed to handle massive inrush currents from things like giant industrial motors or transformers. Because it's so, not very sensitive, it is almost never the right choice for a home. In fact, putting a Type D breaker on a regular lighting circuit would be incredibly dangerous. All right, enough with the theory. Let's make this super practical. Let's apply this to a real-world scenario that you can probably find in your own house right now. Let's head into a typical bedroom. So what do you have in a bedroom? You've got your ceiling lights, of course. You have wall outlets for plugging in your TV, your phone charger, all that stuff. And you might have a ceiling fan, which, remember, has a small motor. The thing is, each of these circuits needs its own specific, correct type of protection. Okay, this is where it all comes together. Let's focus just on the lights for a second. Imagine an electrician installs a Type-C breaker, that general-purpose one, on your lighting circuit. Here's the risk. Because it's less sensitive, a short circuit might not create a big enough electrical surge to make that Type-C breaker trip instantly. And in those few critical seconds of delay, the wire can get red hot and start a fire. But a Type-B breaker, it's sensitive enough to see that exact same fault and trip immediately, cutting the power and stopping a disaster before it can even start. So, when you see how this plays out in just a single room, it really hits home, doesn't it? This isn't just some boring technical detail for electricians. It's about understanding that the things you use every day need very specific kinds of protection to prevent a very, very real danger. So if you remember one thing, remember this: that little letter on your circuit breaker, that B, C, or D, it's not a grade. It's not like A is better than C. It's a job description. It tells you exactly what that breaker is designed to do. And matching the breaker's job to the circuit's load is absolutely fundamental to electrical safety. And so I'll just leave you with this final thought. Your circuit breakers are kind of like silent guardians, you know? They're on the job 24/7, working to protect you and your family. But are they the right guardians for the job? When was the last time you, or maybe a professional, actually took a good look at your home's first and most important line of defense?